Howdy everybody, and welcome back to our Display Manager tutorial series. So last time I left you off with showing you how to create a camera and set up views so that you could make your game any size that you want within reason. So you have to make it within the size of your room. You can't make a game that's larger than your room size or else you're going to have camera issues. But beyond that, so I've done that, but what are we going to do with that? So what if we want our game to be full screen? So let's get cracking on that today. To get started, I've added a little bit of code here. Let's zoom in for that. We have if our window width does not equal our display width, and this is kind of messy code. It wouldn't work in all situations, but it'll work for our situation. Then basically what I'm saying is if our window width is not the same as our display width, then that must mean we're not in full screen mode. So let's go to full screen mode. Otherwise, then if we're already in full screen mode, go back to normal mode. And so this worked fairly well. You can also see I have some extra code here commented out, but you don't need to worry about any of that stuff. It's not needed for this. I also added a little thing in the draw GUI, so just see red, draw 0, and see white. This is just so that you can see where the GUI's top left corner is, so you can see that it changes along with everything else. So let's get started on this. Run a game. And I'll get out of zoom mode, because you're going to need to be able to see this in full screen. Oh, I've also changed the size of the game to 960 by 640 for no particular reason. It could be any size again, like I said. And if I right click, boom, our game has gone full screen. There we go. Get rid of the toolbar down there. So you can see our GUI has changed its position along with everything else to fill our window here. And it's done this automatically to keep our aspect ratio. What is our aspect ratio, you might ask? Well, aspect ratio is simply dividing the width of the monitor by the height of the monitor. Most commonly, as you can see here, about, what is this? At least 60% of web users use a 16 by 9 or 16 by 10 screen. And if you're just focusing on games for Steam, you can see at least 90% of everybody on Steam uses these 16 by 9, 16 by 10 monitors. So you could probably just focus on these resolutions and you'll be okay 9 out of 10 times. But so what if, so this stretches up, but it leaves these black bars here. So what if I don't want those black bars? Well, if you come down to your window, you can change our Windows option in the graphics area to full scale. Apply. Do this, and instead of keeping our aspect ratio, it stretches to full screen. Now, there's a big drawback to this, namely that it stretches everything, and that causes pixel distortion. Because as you can see, my little guy has grown quite a bit stouter. He gets quite a bit shorter because everything has been shortened to be able to stretch to fill the entire window properly. And you know, most people probably aren't going to want that to happen in their game, so we won't do that here. And so what I'm going to show you next is called Pixel Perfect Resolution. It's a method of changing your view size dynamically in order to fill the entire screen and get rid of the black bars. Now, this is alright for some games, but it's not alright for every game. Sometimes there are some places where you don't want that to happen, such as like let's say you have a competitive game and you want to make sure everybody can only see the exact same amount at any given time. So this would not be a good idea for that, because changing your monitor size would then allow you to change how much you could see. And again, like I said, it can change the monitor size, can allow you to change how much you see. So it might affect the way you set up your game or hide secrets and stuff too. So that might also be an issue as well. But again, it's really all based on your situation. Back over to the zoom real quick here. I added a max 1 or floor of this. That way you never go below 1. But it shouldn't be a problem most of the time. Let's add in this pixel perfect resolution here. So we start off with our ideal width and our ideal height. Let's say I want, so the game is 1024, 1024. I can't have any more than that, right? So 1024, 1024. But if I was in a situation where I was on a monitor that was somewhat smaller than 1024 by 1024, then I would have an issue because I would need to be able to, I would then be trying to make my game bigger than the monitor can display, which again is actually a perfectly reasonable way to handle it. You just have to make sure that everything in your game on the GUI and whatnot are inside the area that can actually be displayed. But again, so we want to make sure that we can see everything. So we're going to dynamically resize our monitor here. And just to make sure that we have this issue, instead of using display under get underscore width, I'm going to say 960 here and 960 here, because our monitor is just 960 by 960 and that's a terrible monitor. Okay, so next up, so we're going to need to do some math here. Pound a region, pixel perfect math, not for all games, can be disabled. I'm specifically trying to make sure that you don't do this for every single game. That was kind of one of my problems when I first started with this. Then I thought, oh, this was supposed to be done for everything, but no. There's a situation for this, but it's not. Not everything is perfect for this. So, if display underscore, well, in this case, we'd be saying normally we'd be saying display underscore get underscore width. Mod desired underscore, well, not desired, that's my other code. So ideal underscore width does not equal 0. Then do some stuff, and if display underscore get underscore height mod our ideal underscore height does not equal 0, do some stuff. So this is what it's doing here is saying if our display underscore get underscore width mod ideal width does not equal 0. Mod is a math function that will return the remainder. So in our case we have 1024 and we're going to mod you by 960. So we have 64 left over. That means that our monitor's width does not match our ideal width. We can't fit it in there. It's not going to fit in properly. So we need to do some scaling. So this would be the normal code. And for our purposes, we're just going to use our display width and display height, which you probably should use anyways, because you already got the display width and the display height there, didn't you? So why I was using it, why I was getting it again, well, just because I'm a silly guy who does this a ton. So var d is equal to round this. We don't need to do this again. We could do display underscore our width, and we are going to divide that by our ideal underscore width underscore, And what this does is it says, okay, our display width here is 960 divided by 1024, and we're going to round it. So round it up, that would be 1, right? So in that case, our new desired width, or ideal underscore width, is equal to display underscore width divided by D. So our display width again here is 960 and divided by 1. So our new ideal width will be 960 because we are dynamically resizing our ideal width to match our allowed display size. And we're going to do virtually the same thing here. Var D is equal to round display underscore height divided by ideal underscore height, and our ideal underscore height underscore is now equal to display underscore height divided by D. All right, great. So now we have changed our ideal width and our ideal height to match what we can possibly put into our display. And this works the other way too. So if our display size is 1,300, it will change our ideal width and our ideal height to match 1,300 again, and so on and so forth. There's one other thing we want to do here. So if our ideal underscore width underscore and 1, ideal underscore width underscore plus plus. What this is a bitwise operator that's checking to see if we are an odd number. So if we're an odd number, then add one more point to us so that we become an even number, because even numbers are easier to scale than odd numbers for a GPU. If our ideal underscore height underscore and 1, ideal underscore height underscore plus plus. All right. So what this? So let's see this in action here. Let me make sure that everything should be good. There we go. Now our game is 960. And it's changed the view size and whatnot. So let's see what happens if we set our game to be 240 x 240, a really extreme case. Oops. Our surface resize. Oh, trying to make our surface smaller than it could possibly be. So that's probably not good. 512. It's still doing that? Why are you saying that? What am I doing here? Zoom is, oh wait, display height divided by ideal height. So that'd be 512 divided by the ideal height, which is 1024, and that's giving me 0.5. So it should be becoming 1 due to this max function. Oh wait, yeah, then we have it down here. We're trying to resize this to ideal width. Let's run the debugger on this to make sure that I'm doing the calculations correctly. So 512, and our ideal width is 1024, so it goes through all that. Now our ideal width is infinity, so that's not good. 512 Oh, wait, that's because it's rounding down to 0. That's why. Yeah. Alright, so we don't want to do that. We want to do 514. That way it'll round up to 1. There you go. So as you can see, our view size is changing completely to match whatever our display size is. So that's pixel perfect scaling, and the reason why this is called pixel perfect is because we are maintaining the one-to-one scaling that our pixels would we are maintaining the one-to-one scaling for our pixels, so that when we actually go full screen, well, if this was a full size of our screen, then it would keep a one. It would do a one-to-one pixel upscaling or downscaling, and that's important to make sure that our pixel games keep the perfect pixel look. However, like I said, it's not really ideal for every single game. Like if you have a game that's using vector graphics, you'll find that this is completely unnecessary. You don't really need it at all. And if you don't mind a 1 pixel distortion, which most of the time people won't even be able to see, then you can just leave this out as well, and just let it scale up to normally. Now, if it's really important to you that you maintain that one-to-one pixel option, that one-to-one pixel format, and it's important that you be able to do full screen. So if you want full screen, you want one-to-one pixel, and you don't want your display width and your display height to be changed in any manner by means like this. Well, there's one more option for you, which I will go into on our next video, and that will be Letterbox Mode. So we'll get into that there, and for the time being, I'm going to comment out this part here to make it easier for us next time. All right, thank you everybody for watching, and don't forget to leave a comment if you're interested in learning more, or tell me a topic that you're interested in learning more about, or tell me your favorite NES game that you want to see done as a tutorial or something like that. Anything. You can also find more information about me down over in the information section. So thank you very much for watching. Oh wait, I just realized I did not zoom in on any of that code there. Let me zoom in on that code for you. That way you can get a good look at it if you want it zoomed in. Yeah. Sorry about not zooming in when I was actually doing the coding. Anyways, thank you very much for watching, and good luck with your programming.